Hello, students. It's Monday, November 15th. This is an A day, and welcome to our algebra lesson. And our lesson today is about data representations. We will create and interpret a dot plot, a histogram, and a box plot to represent numerical data. So let's get started. Hopefully you've had your calm classroom. We'll begin with a battery life warm-up. Then we'll have our lesson and our cool down. For homework, I want you to do the 1.2 practice problems that I've assigned in Learn Zillion. So remember, you will be a success when you're focused and ready to learn. You've completed your warm-up, lesson, cool down. You have a lesson summary to read when you are done, and make sure you can access those homework practice problems in Learn Zillion. So let's just focus and block out the distractions and be reminded that you are so worthy of your math lesson today. You're working hard to receive it. You are capable of learning this. You are smart. You are intelligent. You can do it. A good start is to get your name on every page, and maybe this is a good time to make sure you've written down your homework assignment. So let's get started. I'm really excited about today's class. Okay, we're talking about data representations, and the first thing we have is our notice and wonder activity. And I want you to take a look at this activity, and I see three illustrations here. I see the first illustration, the second illustration, and the third illustration. So I want you to look at those right now and just kind of notice whatever you can. You can write it down. You could talk about it with your neighbor. And I want you to wonder, have some questions about this. So I want you to take 5 minutes, stop the video, and notice and wonder about these three illustrations. Okay, hopefully you're done with noticing and wondering. So what we have here in this first illustration is a dot plot. The second graph is a histogram. And the third one is a box and whisker plot. Some people just call them box plots. So we have some questions. We don't have, I'm going to ask you questions. I thought they were written on your page. I apologize for that. So I want you to think about this. What do you notice? And I'll tell you some of the things that I noticed. I noticed that the box plot does have a vertical line of symmetry right here. Okay, I've got a line of symmetry. I don't have that with the histogram, and I do not have that with the dot plot. If I look at these, especially if I look at the dot plot and the histogram, I can see that, that 5.5 hours, well, especially with the dot plot, not so much with the histogram, but with the dot plot, I can see that 5.5 hours is the most common battery life. I can notice that 2.5 hours is not so good, and it's not a good, not very long for a battery in a cell phone to last. I've got things that I can wonder. What do I wonder? Well, what you might be asking is in the histogram, when we're talking about, let's say, 3 hours, is that included in the first bar, or is that included in the second bar? When we're talking about 6 hours, is that included 5 to 6 or in the 6 to 7? So that's something that I wonder. Why does the histogram have intervals of 1? So we have intervals of 1 instead of 2. Here we have intervals of 2, although we have a notation, a tick mark for the interval of 1 on the box and whisker plot. Another thing I would wonder is, how do you get this thing? How do you make that? What does it mean? And that is what we're going to do today. So let's get started with that. We have some data here. We have data that is about tomato plants, and the data represents the number of days it takes for different tomato plants to produce tomatoes. So I imagine that's from the time that you put the tomato seed in the ground until the time when you pick that first juicy tomato off the vine and you are able to eat it. So what we want you to do is use this information to complete the frequency table. And after you complete the frequency table, we want you to create a histogram and then a second histogram. So let's take 3 minutes and let's create our frequency table. Now remember, we're going to go to each value. Here I have 47, so that goes between 40 and 50, so that's 1. 52 is between 50 and 60, that's 1. 53 between 50 and 60, so you're going to just make a tick mark for each one and then tally them up at the end. So go ahead and spend 2 minutes doing that. Okay, hopefully you've finished your frequency table, and the data you should have is for the interval from 40 to 50, there is 1 value. 50 to 60, there are 4 values. 60 to 70, there are 9 values. 70 to 80, 9 values. 80 to 90, there are 6 values. And from 90 to 100, we have 1 value. So now I want you to take that information and I want you to use the axis here. We have the x-axis, which is days to produce fruit, and the y-axis, which is the number of tomato plants. And I want you to create your own histogram detailing the information from the frequency table. Remember, a histogram is this. The blue one is the histogram. So let's take about 4 minutes and create your histogram, and then come back to the video. Okay, hopefully, let's see, for between 40 and 50, that was 1. So I can go like this. I better change my colors a lot. From 50 to 60, that was 4. So from 60 to 70, that was 9. So let's try to make this as neat as possible. With your histogram, the bars touch. They're right next to each other. And from 70 to 80 is also 9, but I will change my color. Okay, continuing on. From 80 to 90 is 6. And from 90 to 100 is 1. All right, there's your histogram. How did you do? So let's keep going. In our next task, we're asked to create intervals that are different. So this time our intervals are 5 days apart. Same information, create this histogram. Let's take 4 minutes to do that. Okay, how did you do? So I'm going to work a little bit quickly on this one. So between 45 and 50, we have 1. Between 50 and 55, we have 2. And between 55 and 60, we have 2. Between 60 and 65, we have 4. Between 65 and 70, we have 5. Between 70 and 75, it looks like 3. Let me neaten this up a little bit. Between 75 and 80, it looks like 6. And between 80 and 85, 3. Between 85 and 90, we have 3 values. And between 90 and 95, 1 value. Okay, so our histogram looks a little different. Let's compare those two. There's the first histogram. We have this beautiful bell curve, and let me get a nice bright marker. This beautiful bell curve here. Okay, but with these smaller intervals, we don't exactly get that bell curve because we have this dip between 70 and 75, and it's a little irregular toward the tail end. So things are a little bit different when we make the intervals smaller. So let's look at this and let's ask some questions. So it often takes some playing around with the interval lengths to figure out which gives the best sense of the shape of the distribution, because that's what a histogram tells us, the shape. So what might be a problem with using interval lengths that are too large? Well, if the interval lengths are too large, we will end up with very few intervals, and the important features within the interval would get lost. One could imagine that eventually we would end up with one interval, so it really almost wouldn't even be a histogram. What might be a problem with using interval lengths that are too small? Well, if they're too small, we might end up with a histogram that is essentially the same as a dot plot. This could be useful sometimes, but in situations where each data value occurs only once or twice, every bar is going to have the same height, and we will not get a good sense of what the shape of the distribution. So the histogram really gives us the shape of the distribution so that we can analyze our data. If we make our intervals too small, we will lose that shape, and we won't be able to see what it is we use a histogram for, which is that to view the distribution. And what other considerations might go into choosing the length of an interval? Well, it's based on context. If it's years, we might have intervals of 10 to represent decades. Common age ranges. We might have yard lengths if we're taking data about sports or football or something. So it usually doesn't make sense to have fewer than 5 bars, or certainly not more than 50. But in the context of your data set, you'll see where to make your intervals. One thing I want to address, if we go back at our first histogram, where would we put 60? Okay, where is 60? Is 60 here between 50 and 60, or it is here between 60 and 70? Well, let me answer that for you. We use the convention of including 60 in the 60 to 70 interval. Okay, so the interval 60 to 70 means all of the values greater than or equal to 60, but less than 70. The interval of 50 to 60 means all the values greater than or equal to 50, but less than 60. Okay, so we would put 60 in that interval right there. So what do we easily see with the histogram? We see the shape of the distribution, and we can estimate the measure of center or the measure of variability. So according to each of these histograms, what appears to be the typical number of days it takes a tomato plant to produce tomatoes? Well, if I look at the first histogram, it looks like it takes between 60 and 80 days to produce a tomato. But look what happens when I answer the same question with the second histogram. Let me get this to roll down a little bit. So again, the question was, what is the typical number of days it takes a tomato plant to produce a tomato that you can eat? If I look at the second histogram, I have a narrower answer of between 75 and 80 days. So thinking about that, let's ask one final question. What information is not seen in a histogram? And in a histogram, we are not able to see the actual values. We would go back to a dot plot for that. So now we're going to make a box plot. So we can, and it's a way that we can represent data. It's another way to look at data. And when we do that, we need 5 values, 5 important values. We need the minimum, we need the maximum, okay, we need the median. The median is just the middle. It's not where you divide by the number of data values, like when you find a mean average. The median is simply the middle. We need the first quartile, and we need the third quartile. So let's take a look at our data. We're going to go back to the data on the tomato plants. And one way to do this is to look at the frequency table. So what would be the median? Well, I see that if I organize this data in order, and that's the first thing you might want to do. I would have 47, and then I have, let's see, I got 47, then I have 52, 53, 55. Okay, some people like to make it in a long line. Some people are okay with it being in this kind of format. But I want to find the data point that is exactly in the middle. Well, how many pieces of data do I have here? I have 5, 10, 15, 20, 25, 30. It looks like I have 30 pieces of data. So I need to know what the middle is. So the middle, here's the first 15, and here's the second 15. Well, I've got 2 numbers in the middle. I have 70 and 72. So what I would do is I would take the average of 70 and 72, that would be 70 plus 72 divided by 2, which would give me 71. And that is my median. So my minimum would be my lowest value, 47, and my maximum would be my largest value, 90. So let's go fill those in with our chart. So I've got a minimum of 47, a median of 71, and a maximum of 90. So the median means that half of the values will be less than 71, and that half of the values will be greater than 71. So now we're asked to find the median of the least 15 values to split the data into the first and second quarters. This value is called the first quartile. Add this value to our table under Q1. What does this value mean in this situation? So the median of the first 15 values, let's go back to the chart. So we do some erasing here so we can see our chart. Okay, so that means we need to find the exact middle. Well, if I have 15 values, the middle would be the 8th value because I would have 7 values below that number and 7 values greater than that number. So the median of the first quartile is 62. And then we do the same thing with the third quartile. We look at the second half of the data. I'll clean this up a little bit. So I can look at, I have 7 data points here and 7 data points here, and the data point in the middle is 78. That is how we find our third quartile. So we need those 5 figures. If we have these 5 figures, then we have everything we need to make a box plot, or we could call it a box and whisker plot. So we've got our median, our minimum, our maximum, our first quartile, and our third quartile. Now, we're going to use our 5-number summary to create the box plot. So we start with our median, which is 71. Put a line there. We next need our first quartile, which is 62. Put a line there. And our third quartile, which is 78. Now we connect those. That's our box. Now we find the minimum, which is 47, and we put a dot, and the maximum, which is 90, and we put a dot. And here you see why some people call this a box and whisker plot, because these are the whiskers. And that's how you do it. That's all it takes to make a box and whisker plot. So what information is easily seen on a box plot? Well, you can easily see the 5 values, the minimum, the quartiles, and the median is actually a quartile. It's like a second quartile. And we see the maximum. And what is the typical number of days that it takes a tomato plant to produce fruit? Well, if we look at the box plot, we see that the typical number of days is 71 days because that is our exact median. So let's think about everything we've done, okay? The box plot lets us see all of the data and how it's distributed. The histogram summarizes the data into intervals and it has fewer columns. The box plot displays the 5-number summary. Now, those are the strengths. The weaknesses of each is the dot plot has many columns of dots, and it can be hard to determine the pattern. The histogram and the box plot do not display the individual values, which means that you can't always calculate the mean. We had the median in the box plot, but not the mean. Um, so if you want to find the typical value for a data set, you calculate the mean or the median and estimate the mean or median, and you can do that graphically. So let's have our cool down. There we go. So what information, well, let's take a look. Let's look at what we're looking at first. We have this dot plot, a histogram, and a box plot that represents the battery life in hours on a phone. So the question is, what information can be seen most easily? What information can be on the dot plot, on the histogram, and again, what information can be seen most easily in the box plot? So go ahead and take 5 minutes and work on that. Okay, let's answer those questions. The information that can be seen most easily on the dot plot are the actual values, the shape of the distribution, and the most common values. So those three things, the actual values, the shape of the distribution, and the most common value. As to the histogram, we can easily see the shape of the distribution. This is where the histogram really shines. And we can see the most common interval of the data. Remember those intervals, those distances between each of the numbers on the x-axis. And in the box plot, the information that can be seen most easily is the 5-number summary. Remember the minimum, the maximum, the median, the first quartile, and the third quartile. So I want you to spend the next few minutes till class is over reviewing the lesson summary. I want you to read this more than once. Please read it twice. And remember, you have those homework problems assigned in Learn Zillion. And before you go, remember to clean up your area and don't forget your things and return any supplies you used. So great job today. I love how hard you're working. And remember, with math, especially with algebra, with practice, you'll be great. Have a wonderful day.